Hello, everyone, and welcome. I'm Dave Moore from Growth Acceleration Partners, and I'm joined here today with Sergio Morales, who is our data architect and development lead on the Transformation Services Division. We're going to show you a demo today of what we refer to as the modern data and analytics platform. So you're about to see some infrastructure as code, creating a scenario, deploying it to your cloud environment that lets you rapidly get to time to value. So let me start by saying that when we took on the initiative of building such an architecture, as a organization at GAP, we've been doing these things for a while, and then we noticed that we were repeating ourselves in what we were deploying for customers. That, coupled with the fact that with these services offered by cloud providers, we believe that there is a best practice for how you would implement these things to satisfy most of your common data needs. So I'm going to ask Sergio here, because we took this is one of our favorite screenshots out of a book called AWS Data Science, that we would use this, as you know, Sergio, with customers to say, is this what you're trying to do? Are you trying to do these types of things with data? So Sergio, if you don't mind walking us through this diagram at a high level, what we're building.
Yeah, absolutely. So first of all, as you mentioned, that this is taken straight out of one of the most well-regarded books on the matter for data pipeline design and implementation. And I think it's important to stress that we're not really reinventing the wheel. We've really taken what we've seen within the industry that's highly requested, highly practical, and is highly easy to integrate between different sorts of tools and process flows and other sorts of workflows. So what we have here is basically a three-stage design where we have a ingestion step coming from different types of sources, such as real-time data, batched data, data that is being currently held on on-premise sites, and is ingested homogeneously to the degree where that is feasible into a three-tiered storage approach, one that is, again, industry standard, with a landing zone where all of the information as ingested is preserved to be later homogenized further into a single format, in this case, Parquet files, but they can be other sorts of formats, and then later provided by a curated zone to data consumers through a curated data catalog that is supported by services that provide different degrees of access to different roles within the organization through the analysis and data science tools that these consumers are going to require, be they data analysts, data scientists, or business users.
Thank you, Sergio. So we have multiple data sources coming in. There's a landing zone and a transformation area, and then multiple different types of consumers. It might be a data scientist doing machine learning. It might be a SQL ninja building dashboards to satisfy all those types of users. Great.
Yeah, absolutely.
Okay, so at GAP, we took that as a blueprint, as well as our GAP expertise that you'll see here in the bottom. Both you're going to see an AWS and Snowflake option that you have. We use that with customer requirements, and there's one of the books that I referenced earlier with our diagram to see if we missed anything. So we check out those types of resources. Those are valuable to us. And then we are big fans and believers in the AWS well-architected framework, Amazon's approach to how you build things like this. And then finally, on the far upper right here, you'll see what we refer to as the GAP Accelerator, and that is infrastructure as code, Terraform, that we have built and pre-wired all of these things together. Anything else here, Sergio, that's worth pointing out to our viewers?
Yeah, what I would say is this allows us to have a highly customizable sort of accelerator that is going to implement not only a collection of best practices within, again, what is data pipeline design and implementation, but also allow us to integrate customer requirements in order to tailor this deployed platform to their needs. And this is all packaged within a Terraform infrastructure as code deployable package that will execute in minutes.
Perfect. So Sergio, this is where the rubber meets the road. This is our implementation of that high-level graphic. Walk us through here from an AWS and a Snowflake perspective.
Absolutely. So here we have the three layers that I mentioned before, clearly graphed. It's worth mentioning that there's a lot of intermediary steps that are not being seen here, such as the plumbing and infrastructure that you need for all of these components to work together and to communicate with each other, having the right degree of access between them that only allows them to do what we need them to do. So what we have here is a variety of data sources. Again, they may be coming from real-time IoT applications, click streams, and other sort of API-based inputs. We may have batch documents that are uploaded directly through a standard put interface or something similar. And we have databases that may be currently hosted either on-site or on some other cloud platform. After this, we have the ingestion components, which we can break down into those oriented towards ingestion for real-time data, such as the kinesis streams and the record transformation functions that support our homogenization processes, which make sure that even if you have separate real-time sources with a variety of sorts of formats and column layouts, you're going to be ingesting a homogenized file at the end, which is going to be both stored on the bronze landing area where the original data is going to be preserved as it was received from the API input, and the silver transference area where we're going to be holding the homogenized files. Further, we have automatic processes that transform this data for consumption and puts it in the gold data area where it's going to be available for consumers and properly curated through our glue catalog, where all of these sources are going to be declared and all of the data dictionaries are going to be available. From this clean data, we are able to both utilize data-oriented services within the AWS platform, such as Athena and SageMaker, and all of these that may be used by end consumers, while all of this is being organized within Lake Formation, so that we are properly able to organize who gets access to what to a columnar and row level. Alternatively, this is also ingested by Snowpipe as an alternative, where whoever's using, again, Snowpipe resources is able to get to this data and utilize it through whichever data analysis or data science processes are available on the client's Snowflake's interface.
So Sergio, we have, I see the Redshift cylinder image, and then we also have Snowflake. I assume this is like a configuration option. I could go one or the other or both or neither.
Yes, as we mentioned, we have both designed the MDAP, the Modern Data Analytics Platform, to be highly customizable and modular. So many of these features can be turned off depending on the client's needs, both to tweak the performance of the pipeline and the features that it enables themselves.
Great. And this S3 bucket in the gold zone, would you say that would be considered a data lake where I could do some unstructured data type things with Amazon tools or things that I want to do there?
Yeah, This three-tier design is, as we've said, industry standard. So the best practices for working with data that is curated and declared within a catalog are all available through that gold endpoint, while the original data and the data without further transformations are preserved within the other two buckets, which, by the way, are going to have lifecycle policies associated with them that make sure that we are taking care of that data and making sure that its life cycle is coherent with the organization's goals.
That's what I was going to ask you, Sergio, because like Terraform on like an S3 bucket is pretty trivial. I can do that with a little block of Terraform code. Would it be fair to say the hard part are the black lines and the arrows here, getting all of these components to work together in a secure and performant way?
Yeah, anyone who's familiar with the Amazon way of doing things will know that all of these components have to communicate with each other. And that implies creating policies, making sure that each component has only the correct permissions that they need so that they can do what they are required to do and no more. And all of this tweaking is happening behind the scenes through our Terraform code.
As the development lead on this, we're not sales guys here, we're engineers. If someone wanted to build something like this, after you and your team built it, how much time do you think it would save them if they're like, yeah, these are the types of things that we want to do. We would like to use something like that, but we're going to build our own. What would you say?
A conservative estimate, I think, would be around 4 to 5 months, maybe more, especially if you want it to be as modular and you want it to be as easily redeployable on other environments.
Okay. Well, I think we have a good prelude to Brayan, and we're going to hand it over to him to show us the nitty gritty and the nuts and bolts and actually deploy this infrastructure.
Take it away.
Okay, thank you guys. So now we're gonna review the deployment aspect of the accelerator template. What we see here it's the Terraform code that will handle the deployment execution of the entire platform. It consists on resources that work together in order to perform a specific action in the AWS ecosystem. So we have a private virtual cloud. This is just networking, basic networking for the infrastructure. We have some security components based on policies, roles, or security groups. These policies and roles are needed in order for the different resources in AWS to be able to communicate with each other and perform different actions between each other as well. We have a Redshift cluster and we have a Snowflake cluster as well. The Snowflake cluster is optional, so we deploy or not the infrastructure based on requirements on needs of the deployment. So basically, what we have to do is run on a specific installation command. In this case, we execute make install, and what we will do is that it will go and read all the different aspects of the Terraform code and deploy them in sequence. After the end result of the deployment, we will get an output like this. In this case, we have two different kind of data ingestion methods. We have batch and we have stream. So for the deployment execution at this time, we only have deployed a batch pipeline. Because of that, we are getting the output of what the batch bucket is on the bronze level. And if we need to, Redshift credentials and commands and endpoints. The execution takes some time, between 1 to 20 minutes, or between 20 to 30 minutes. So right now, we have not deployed the solution from scratch, but we have only deployed a piece of it, so we can get it running a little bit faster. So what we see here is that Terraform is comparing each resource that is deployed on AWS and match it with each resource that we are requesting from the Terraform code. And it's refreshing the state, which is a file that has the correspondence of resources that exist and resources that we want. So after it finishes checking which resource or refreshing the state of the Terraform execution, it will then output the corresponding parameters that we need in order to perform the following actions. And now we're gonna see how we are able to leverage these deployment parameters. Now we're going to create a batch data source or a batch pipeline. These are directly uploaded into S3 buckets because it's meant for a large files. So we're going to name it. For example, and we are going to select a configuration file that corresponds to my batch schema. So we have samples here for Brayan stream. We open it, we register source. This Goldtron is for the transition between data that is already ingested but not transformed. We have a cron job that is going to be executing at the time that we tell it to. How we want to transform our data between our silver stage into a gold stage. Gold stage being the cleanup data and useful data that we're going to be using in analysis. So once we have added the register source, we're going to see our source metadata between the stages, bronze, silver, gold. We are going to have our data itself, which is in this case physical data. Or zero. This is for silver. This is for bronze, silver, and gold. Since we already have this already loaded, then it's just a matter of uploading my data into a S3 bucket. For this, we have created a script that allows us to upload a large amount of CSV files into our bronze bucket. So using our example, we execute it, and now the bucket should contain our data. So this is the data that we have uploaded into S3. Now, because we need a transition between our raw data into our silver formatted data, we're using Parquet in order for your raw data to be more useful and more accessible. So for this, we have some ETL jobs that execute transitions between bronze, silver, and then silver to gold. So in this case, we have Brayan string. This is the glue job code that is transforming our data from a CSV format into our Parquet format and putting it into our silver bucket. So we're gonna run it, and we can see how the execution is going on right now. In the meantime, we can check what kind of data through Athena we have ingested using our CSV file. And as well, we can check on our bronze data. Then we don't have yet any type of data because the glue job is the one running the execution right now. So when this is finished, we are going to be able to see how our data has been ingested into a podcast format. The same thing we have for our goal bucket. The goal bucket is meant for already filtered data, but we have not yet run the script because we need to wait for the script execution to finish. So now that the execution has succeeded, we are able to run the query again in our silver bucket. And now we have the same data, or the data that has been transformed into a podcast format. The same process we can execute from silver to gold. Right now it's the same script, but this is just an example on what capabilities we have in order for our transition to be between one stage into another one. So this is pretty much it with our batch integration. And now we're gonna see how our stream ingestion works. So now that our silver to gold execution has finished, we should be able to query our data for our gold bucket. So as we can see, we now have data on our gold bucket. In this case, we are gonna, now that we have loaded our data into our filter or the last stage of our ingestion pipeline, we're gonna turn it over to Philippe, our data scientist.
Thank you, Brayan. So now that the high quality data is in the S3 bucket, the gold S3 bucket, we can leverage any of the several AWS technologies for consuming that data and creating data-driven products. So for this demo, what we're going to do is use Amazon Athena. So the way Amazon Athena works is that by specifying a schema, you can actually query plain text or Parquet files that are stored on your S3 buckets directly. So for example, here, I got a truncated version of the Amazon reviews dataset, and I can just run the query and I'll get the results down below. So this is a very quick way to get easy insights from this. However, we most likely want to have a deeper view of the data to build more robust products. So what we can do is leverage Athena's ODBC connection. And the way you set this up is you download whatever connector you need. And then on your laptop or your machine, ODBC, you can just go to the system data source names and create one for Athena. So the fields are very much straightforward. You just fill those in, and then you have a connector that can be leveraged for any type of technology. So of course, we would probably want to do some sort of machine learning model to predict sales or reviews or something like that. But for today's session, we'll just go through building a very simple dashboard for this. So I'll set this up in Power BI, and I'll just get the data from there. And you just have to select Amazon Athena, and then just point to your DSN that you previously defined. So here you will get two options. You can either import or perform direct queries using Athena's engine instead of your own local resources. And here you can see that I can directly access the Amazon reviews file that we were using. So once we have that, we can perform the building of an actual analytics product. For example, here I have this quick dashboard I just spin up. And as you can see, if I query you get a few moments of loading information, and that is because we are actually not using my resources, but doing a direct query from AWS Athena. So I'll now send it back to Brayan for him to show us a different way of ingesting data, which is real-time data.
Okay, thank you, Philippe. So right now, what we're going to do is to show how the data stream through Kinesis works. Right now, what we can do is to create a new data source. We can call it Excel stream. And we need to choose a file that corresponds to the schema of the data source that we're adding. That's where we can add a control and register the source. Now we have the metadata, the schema for the bronze stage, and the schema for the silver and gold stage. The way that the data is going to flow is through a series of steps that will transition the data between each state of the data link. For ingestion, we're using API gateway with an API key, so we can authenticate the source. And we have different data streams. What we call a data stream is a collection of AWS resources that work together in order to manage the life cycle of the data. So in this case, we are ingesting the data through API gateway. We are channeling it through Kinesis. So in this way, we can convert from a JSON formatted ingestion to a Parquet formatted save version of it, and we can place the raw data into a bronze bucket. Then we'll have a ETL job through a glue job. You can see it in here. This is the code for the glue job. What this does is that it takes the structured or schema data and will transform it in such a way, in a way that we want from the silver bucket, and it will place it into the gold bucket. The transformation is up to whatever we need to do with the data to refine it. But at the end is just the process that will change, the middle process that will change. In this case, we are just mapping some columns and removing other ones. When we run this execution, then a glue job will start to execute. We'll be able to see it once it finishes into an Athena query editor in the right table. So this is the part here, a glue job. And then the glue job will move data from silver to gold. And on the last step, we have either two scenarios. We're using Redshift from AWS, which has a direct connection into the S3 bucket, so we can read data using the heavyweight lifting of Redshift on computing power. In the same way, we can add an integration directly from Snowflake that whenever something gets placed or a Parquet formatted data is placed in the gold bucket, then it will trigger an automatic loading mechanism into a Snowflake table as well. So we can check it here. Still running. And if we run as it runs, we can check on the gold bucket, which in this case is weather 3, the data that has been ingested. Right now, as an example, we are ingesting weather data. We're using the Open Weather Map API in order to collect data from different sources in the world. So right now we are using London as an example, and we are collecting weather data from London. It's an JSON formatted version of it, and this is the response from the API loading the data. The way that this schema works is that we need to save in a JSON format the response from the API, and in this way we can deploy the infrastructure related using the proper schema for this data pipeline or data stream. Once we have collected enough data and the Glue job has finished running, succeeded, then we'll be able to see more data in the Go bucket. In this case, we have almost 400 data points. And we can also go to Snowflake and check on the tables. So we have two in this case. This is for a batch stream. So we don't have any data loaded yet. But for the Excel stream, now that we have gold data, then we'll be able to see it as well as Snowflake. Okay, so now that we have data loaded in Snowflake, I can forward this to Philippe so he can show us how we can manage dashboards and create analytics with the data. Thank you.
Okay, thank you very much, Brayan. And now that we have our high quality data set up and ingested on Snowflake, we can actually start developing and building analytics and data products. So I'll just go ahead and quickly look through our data ingestion process. You can see that now it's sitting on our Snowflake database, and I can actually just quickly query it from here directly through Snowflake's worksheets. But again, we probably would want to have a more robust connection to build actual analytics products. So for today's demo, I'm going to just set up a quick Tableau dashboard. And the way we do that is just spin up your Tableau program, and you can directly connect from to Snowflake. So I'll just set up my credentials here, and this will bring me to my usual Tableau interface for connecting. So here I can select our database of choice, our schema, and then I can just drag and have my data ready to go. So this is weather data. So I got to quickly set up this demo. And again, this is done with a direct connection, which means that the compute resources that I'm using are the ones that Snowflake provides. It's not my local machine running the query. So this means that I can easily and painlessly do as large as my dataset is any type of process in here. So I can just go ahead and wonder what's going on in Czechia. And here we go, a quick overview of our weather. So now I'll turn it back over to Dave and Sergio for final comments.
Thank you, Philippe. And Sergio, this dashboard that Philippe just created, pretty impressive in a very short time frame. Walk us through here the data pipeline and the code execution path.
Yeah, absolutely. So this one is a pretty natural workflow for what we would consider a standard dashboard creation flow. In this example, we have batch documents being uploaded directly using our pod endline endpoint, which is deployed as part of the overall accelerator into the landing area, where it is automatically picked up by an automatic process, which is going to homogenize the data into Parquet files, which are columnar-based formats that are able to be queried in a more efficient manner for the queries that are usually done when creating these sorts of data work. This data is later transferred into the gold data area, where it is ready to be consumed, and it has been properly registered within the Glue catalog so that people can consume it and that they have the rights to consume it as defined by the policies in the lake formation component. In this instance, what we have here is this data being accessed through Athena and then being passed over using Power BI's integration functionalities with AWS, at which point it's just a matter of building a dashboard as you would with local data.
That's pretty awesome. And what an awesome looking dashboard that is as well. So great job by Philippe. And then the other one that we had was the real-time streaming. So, and this one ends up in Snowflake. So obviously it goes through a different path here. Walk us through this one, Sergio.
Sure. So in this case, what we're doing is we are ingesting real-time data through one of our Kinesis streams. The actual ingestion is handled through another API endpoint, which is just as easy as it would be to send data over to any API. But this case, the Kinesis Firehose stream is gathering all of that data, uploading it in batches through the bronze landing area, but not before applying record level transformations on which we can individually edit each record that is coming through in case that there are transformations needed at this point. The middle of the path is exactly the same. We land on the landing area. This is later transformed and homogenized into more Parquet files on the silver bucket. And then it is located, curated, and cataloged on the gold data area for users to retrieve. In this case, what we have is our Snowpipe functionality enabled such that it is able to be directly sent over to a Snowflake staging areas where you can build, as you know, dashboards from using tools such as Tableau, which is what's being used in this case.
So Philippe used Tableau in this one, Power BI in the other one. We don't really care what dashboarding technology they use, right? We can support any of them that can connect to these data sources.
Yeah, as long as the data is readily available on a format that lends itself well to these integrations, you are ready to go.
Well, that is great. And I'm going to stop sharing and appreciate you walking us through this, Sergio. And for the viewers watching the demo, if you have interest in learning more about the modern data and analytics platform, please reach out to us. You can find me or Sergio on LinkedIn, on the GAP website. We'd be glad to walk you through other things, or if you wanted to run the code and the Terraform code in your own environment, we'd be glad to let you do that as well. So thank you, Sergio. Thank you, Philippe. Thank you, Brayan. And please reach out to GAP if anyone has any questions.